Right. Hello, everyone, and thank you so much for joining us today for the Quantum Speaker Webinar Series hosted by HRC's Global Quantum Working Group. I'm Elizabeth Wyckoff, HRC's Working Group Program Manager, joined by our group chairs, Allison Schwartz, Lily Chen, and Terrell Franz. Today, we are very excited to welcome David Stewart. David is the Managing Director of the Purdue Quantum Science and Engineering Institute, or PQSEI. In David's role as Managing Director, he works alongside the PQSEI Director and faculty to promote interdisciplinary research endeavors and to build collaborations and partnerships with industry, government, and other academia in order to advance quantum science and engineering. David also serves as the Industry Liaison Officer and Managing Director for the Center for Quantum Technologies, an NSF-funded industry and university cooperative research center. There will be time for questions at the end of the presentation, so please feel free to utilize the Q&A feature or raise your hand and you'll have an opportunity to speak. So with that, we will hand it off to you.
Thanks very much, Elizabeth, for the introduction, and thanks to Allison very much for the kind invitation to present. Let me see if I can get my screen shared here. Okay. You see that, Elizabeth?
Yes, we can.
Good. All right. So yeah, thanks again for having me. I'm the Managing Director of the Purdue Quantum Science and Engineering Institute. My primary focus of the webinar today is to talk about the Center for Quantum Technologies, but I do want to take just a few minutes and talk about some of the ongoing efforts in quantum science and engineering that we have at Purdue. So a lot of words on this slide, and I don't want to read everything here, but our Quantum Science and Engineering Institute at Purdue, works to integrate quantum systems into tomorrow's technology via interdisciplinary collaboration to help realize industry-friendly quantum devices that will impact a vast community of users. And of course, as an academic institution, we also work to train the next generation of quantum scientists and engineers. So just a small sampling of some of our ongoing areas of expertise that we have, and I have another slide covering more of these in a little bit. So at Purdue, we currently have 54 faculty members affiliated with our institute, about an even mix from the colleges of science and colleges of engineering. And most are in our physics and electrical and computer engineering departments, but we do have some from a variety of other departments, including chemistry, math, computer science, and some other engineering. So we've grown significantly over the past few years. When PQSA was founded in 2019, we had about 25 faculty members, and as I mentioned, we're at 54 today. We've hired about 20 new faculty members in quantum science and technology in the past decade. So really working to boost our efforts here in quantum at Purdue. We really have expertise in almost every area of quantum science and engineering and technology development, from quantum materials and devices, lots of semiconductor research going on at Purdue. We have great expertise in quantum photonics and AMO physics, as well as quantum chemistry, quantum control and measurement, simulation, and informatics, computing, data, machine learning. So really every corner of quantum we touch here at Purdue and have great expertise in all these areas. So at Purdue, we have several major initiatives into our standard research, individual PI research efforts. So I just want to mention a few of those here. One is we're a core partner in the Quantum Science Center, which is one of the 5 DOE-funded NQI centers. So the QSC is led by Oak Ridge National Laboratory, and it supports about 14 of our faculty here at Purdue and over 30 combined graduate students and postdocs. So a really big effort for us. That center works to develop topological quantum materials, create algorithms that exploit those topological systems, and then demonstrate new devices and sensors. And Purdue also leads the workforce development efforts of that center under the direction of Professor Sasha Baltaseva. We actually just held a couple of weeks ago our 3rd annual Quantum Summer School, where we had over 100 students in attendance at Purdue. So really exciting event for us. We are founding members of the Midwest Quantum Collaboratory, which is a relatively new partnership with Michigan and Michigan State, trying to bring our faculty together, but also try to engage with industry and government partners. We're also a partner in the Quantum Collaborative, which is led by Arizona State University, which has efforts to advance quantum information science and technology and build workforce development efforts and drive the U.S. quantum economy. And I will tell you a little bit about the Center for Quantum Technologies next. But we also have several other major projects ongoing here at Purdue. And I'm happy to share this slide deck at the end if anyone is interested. So on to the discussion about the Center for Quantum Technologies. So this center is a partnership with Purdue University, which is the lead site, and Indiana University, both their Bloomington and Indianapolis campuses, and the University of Notre Dame. And it's a brand new NSF-funded industry university cooperative research center, which I'll certainly tell you more about what those centers are and what they do. So called the Center for Quantum Technologies. We've gotten both planning grants and a phase 1 award for this center. So go on. So IUCRCs are NSF funded centers that have been around for about 3 decades. Their main goal is to catalyze pre-competitive use-inspired research. And they have 3 primary objectives, and that is to conduct high-impact use-inspired university research to meet the needs of its industry members, enhance U.S. global leadership in driving innovative technology development, and to identify and mentor and develop a diverse, highly skilled workforce, which for quantum we know is extremely important right now. So IUCRCs bring together government, academia, and industry in order to do these cutting-edge, pre-competitive basic research efforts in science and engineering to drive innovation and societal impact. So NSF provides funding for these centers, and other government can join as well. We have a couple of DoD labs that are involved. The universities do all the research. They have the infrastructure in place to do that, and industry comes together to provide funding for the research project. So you can see here that IUCRC focus, is a little bit beyond just basic research, sort of in this gap between commercial deployment and technology readiness, and sits here in this sort of TRL 2 to 3 type level. So here's our leadership team. Purdue is the lead, so Professor Sabre Kai is the Purdue site director and also the overall center director. He's a professor of chemical physics here at Purdue. Peter Kogi is the Notre Dame site director, professor of computer science and engineering, and Gerardo Ortiz at Indiana is the site director there, and he's a professor of physics. So as mentioned before, I serve as our industry liaison officer and managing director. So I do most of our correspondence with our industry and government partners and manage all the operational aspects of the center. And I mentioned that IUPUI is also a partner. That's Indiana. It's a joint campus of Indiana University and Purdue University in Indianapolis. And Ricardo Deca, who's a professor of physics there, is the director of the campus site at IUPUI. So we all had great relationships before we started this journey, all located in the state of Indiana. So it's easy for us to work together, and that it made a lot of sense for us to come together to start this center. So we've been on quite a journey getting this center launched. We started planning this over 3 years ago, late 2019, early 2020, where we came together with IU and Notre Dame to talk about starting this. And it really began because the Purdue Quantum Science and Engineering Institute director, Professor Yong Chen, met one of the NSF program directors at a conference maybe in 2018, and he mentioned there was not a quantum IUCRC yet. So that kind of sparked our interest in going after this center. So we've held multiple workshops, held just a workshop in June of 2020 in the middle of virtual workshop, in the middle of the pandemic. That gave us a lot of insight into what prospective members were looking for. And we used the information we gathered there to submit a planning grant proposal. And that was awarded the next year in May of 2021. And then we really started getting into the center more, attended a NSF boot camp training to teach us best practices and how to run these centers. We did about 100 interviews with prospective members to hear what their interests and needs are. And then we held our planning meeting in the fall of that year. So from out of that meeting, we got feedback, and that allowed us to present a really good proposal to NSF for a phase 1, which is a 5-year award, which we got last fall. So we just held our inaugural meeting where we did project selection in February, and projects actually just started on Monday of this week. So we're finally actually getting to do research, which is great. So just a little more about IUCRCs. They can include for-profit organizations, which is the large majority of them, but can also include not-for-profits, also state and local agencies, and other non-NSF federal agencies. I mentioned we have a couple of DoD labs that are in the center. They come together and form an industry advisory board with one representative from each member. So there's a single membership agreement that NSF has approved that all the members sign. And these centers are really unique in that the research projects are all funded by the member fees, and the members actually collectively select the projects in a voting process. So our members really have a lot of influence in the research direction of the center. So our membership fees are listed there. Most members are committed at our full membership fee, which is $50,000 annually. But there's also a couple different membership levels that just have a difference in the voting rights that you get. So again, NSF provides all the funding for admin and management costs. All that covers all of our meetings that we have, travel, publication costs. It's one of the rare instances where NSF does not actually provide funding for research efforts. So that all comes from the member fees. And they provide all that funding, and it comes in at 0% overhead, which is great. At Purdue, that number is typically 50 or usually 57%. So every dollar that our members put in go 100% to research efforts. And then the universities have the infrastructure, world-class facilities, and researchers to conduct that research. And then out of that, the members get access to the pre-competitive research results and the highly skilled workforce. There is significant value in these centers for the members. One is they get access to all the talent, opportunity to directly interact with students and postdocs in the center. And this statistic that I show on that slide comes straight from NSF, which is 25% of students that work in these centers eventually become employed by member companies. So a great opportunity for industry and government to get interaction with prospective employees. There's risk mitigation because the members are sharing these risks of early stage research with the other industry peers. Lower research costs. Of course, funding a grad student is much cheaper than hiring a new full-time employee. And we already have great facilities and infrastructure in place, so we don't have to pay for those things. So significant savings there. And they get to leverage their research dollars. They're putting in, well, not a small amount, but that $50,000 membership fee becomes much bigger when you pool it with the other members. So significant leverage on the investment, which I'll talk about on the next slide some more. And then networking opportunities, not only with the other industry and government members, but also with the faculty and students in the center. And then a big one is that all members get royalty-free, non-exclusive licenses to any IP that's produced in the center. And so here's a little more just about that leverage on the investment. Our full membership level fee is $50,000 per member, and we currently have 11 full equivalent members. So that comes in at $550,000 in membership fees and $450,000 that we get from NSF a year. So we get $1 million annually. So a $50,000 membership fee leverages $950,000 annually. So currently a 19-to-1 leverage, and we hope that number ratio just continues to grow as we add more industry and government members. There's also great opportunities to to get supplemental funding from NSF and to support student efforts in a variety of areas. But I just wanted to highlight the intern program, which NSF will cover all the costs for interns to go work at our member organizations for up to 6 months. So a great opportunity for our members really to get a fully paid intern, from NSF. So this is sort of our annual tempo of the center in regards to our project selection. So we just had I will start at the bottom here, which was our spring meeting that we just had in February, and that was our project selection meeting. What happens at those meetings is our faculty from all the universities come together and they will pitch projects to our industry advisory board. And then the board collectively selects which projects are funded. So at this most recent meeting, we had 15 projects that were pitched, and they ended up selecting 7 of those. And so now those projects are just getting underway. We'll have continuous dialogue with the industry advisory board through regular monthly meetings that are set up for each project. And then we'll all come together again at the fall meeting. And at that meeting, we will review the progress of the project so far, get feedback and guidance on those to help those move forward. But another big thing that happens at that fall meeting is we will hear from our industry members on what projects they would like to see in the next round of proposals. So essentially which projects they want to see pitched at the next spring meeting. So that not only helps us refine the projects that are currently underway, but helps us really get a good idea of what they're looking for the next round of projects. So as projects are completed in this first year, those can be recompeted for funding again the next year, but we will also again bring in new project proposals with guidance from our industry advisory board. So the main takeaway here is that throughout this process, the members really get to determine the research direction of the center. Yeah, so a lot of words on this slide, and I don't want to read everything, but just want to highlight that across our 4 campuses, we have over 100 faculty working some area of quantum information science and a variety of areas. So it gives us extreme flexibility in being able to meet whatever needs our membership have. So that being said, we've defined a few key research areas. Those are algorithms and architecture, materials design and chemistry, communications and networks, finance and business, and quantum sensing and hardware. So this is what we've designed as our roadmap for the center. And so over here on our left, as you can see, we want to, really overlap where our faculty and student expertise lies with whatever our membership needs are. And these are going to be our key research areas. And so out of that, we'll get member relevant pre-competitive research results, help grow a highly skilled workforce, and hopefully develop some state-of-the-art quantum technologies. Just want to highlight these are our projects that were selected for year 1. And so these will all run for 1 year. As the center evolves, we might have longer running projects, but these are the ones that will start just for 1 year. So as you can see, we have representation from all the different campuses that are involved. Several projects have cross-university collaboration. And then we're touching on all the different key research themes within the center. So we're excited that we have good diversity in our projects, both in terms of the research areas and in terms of the campuses that are involved. I probably don't need to go over this slide, but I just want to highlight that this center will directly follow several of the key efforts that the National Science and Technology Council described in the strategic overview for quantum information science that was released maybe in 2018. It's been 5 years now since that came out. But one is to focus on a science-first approach, which as university researchers we will of course do. And then also as universities, we're going to help grow a workforce that we hope is quantum smart and diverse and to really meet the needs of our membership. And then by the nature of the center itself, we're going to encourage industry engagement. It's mandated in IUCRCs, right? So all these things that are laid out in the strategic overview for quantum information science, the CQT is going to do. So we really hope that the center is growing an ecosystem that's bigger than just the projects within it, right? We hope we're bringing people together that are going to build strong relationships, lead to side projects and external collaborations to really solve some of the grand challenges facing the industry. So I would like to thank all of our committed members. There are, I think, 14 of them right now. There's a few more I hope to be adding soon. But as you can see, we have a really diverse group. We have Department of Defense labs. We have, niche quantum computing companies. We have automotive manufacturers. We have drug companies. So it's a really great group, and we're looking forward to working together, bringing folks from very different areas together to solve some of these grand challenges that we're facing. So with that, I wanted to leave about 10 minutes for questions. So I'm happy to answer those. And of course, we'll share the slide deck. But if anybody is interested in membership or just learning more about the center. And also I should mention, this was somewhat geared toward prospective industry and government members. But there are options to add other universities to these centers. We're not aggressively pursuing that, but if there's a university out there that makes a lot of sense, that can bring several industry members and provide some areas of expertise that we don't already have, we'd certainly be interested in discussing that. So any questions I can answer now, or please feel free to email me also at davidstewart@purdue.edu. So
Thanks so much, David. Really appreciate it. We actually do have a few questions that have come in. I'm happy to read them for you, so you don't have to go digging for them. One question was about intellectual property and how it's treated for the funding applicants. I know you had mentioned there are some IP rules. If you want to just kind of give a quick blurb about the IP.
yeah, so I'll preface this by saying I'm not a lawyer, but I'll do my best. So the universities own all the IP, but all the members get royalty-free license to any IP that's produced in the center.
Perfect, thank you. There's another question that asks, can applicants for these IUCRC funds also access other government, nonprofit, or private sector funds for the same project? This is coming from somebody from government. So I guess the question is, if they were to come with you, are they allowed to, is it kind of only through the CQT, or could they potentially get external funds as well for the same project?
So the funds that are, the member fees that are paid will only support, the projects within the center. But NSF certainly encourages, external projects and encourages us to seek other funding opportunities. So, as I mentioned, we're hoping this is growing an ecosystem bigger than just, we currently have 7 projects. We hope it grows bigger than that. We hope it, leads to member A forming a relationship with member B and then working with university X or whatever, to work on side projects. So there are certainly opportunities to find external funding for projects.
Perfect, thank you. I just have a quick question that, you'd mentioned these 7 projects. Are they all moving along at the same timeline? How are the different projects kind of staggered to make sure that folks who are engaging understand kind of what the time, you had mentioned they come in and out, but are all the projects on like a 6-month or 24-month kind of cycle?
Yeah, so just good question, Allison. To start, everything's funded just for 1 year. And that's really just because that project selection has to happen at the same time where we select all the different projects. So everything's slated just for 1 year to start. But there is potential, in year 2 a project may come in and say, this is really a 2-year project. We can't accomplish all these tasks just in 1 year. We'd really like to get funding for 2 years, and then the IAB could decide if they want, to support that and guarantee them funding for the second year. And then, but when it would come time for project or project selection in the following year, there would be a smaller pool of funding. So that's just up to our industry advisory board to weigh, but they ultimately get to decide that.
And when the projects are submitted in, is there a timeline for those projects that are also submitted in at the same time? Sort of like, I remember there was the quantum playbook that had a different timeline than some of the other works.
So at least for this first year, they were all just for a 1 year duration.
Okay. Perfect. Thank you.
Okay.
There is another question that came in. Can you share some of the significant or surprising results of the projects executed so far? So David said it just started on Monday. So I don't know if there's any surprising results at the moment.
Hopefully in 6 months. Yeah.
You mentioned the $50,000 to join. I know we have some government folks who are listening in. Is that $50,000 for government members as well, or is there a different structure for governments to engage?
That is the same for our government members. So as I showed on our slide, both our members slide, both AFRL and NAVSEA at Crane are members, and you're able to do join via an interagency agreement if you are government, and submit your funding through a MIPR with NSF.
Wonderful. We have a few minutes left, so folks want to pop in more questions. Otherwise, I'll keep going. Is there an exciting, like 5 years from now, where do you hope to see the CQT be?
Yeah, that's a great question. Hopefully, substantially bigger than it currently is. It was a lot of effort to get it off the ground, especially with the pandemic and uncertainty and everything. So, I hope our membership is at least doubled, or, I'd like us to have, 30 members in 5 years. That'd be great. And with that, I hope that we do add some other university partners. We've talked about even adding international university partners to really expand the reach of the center. So nothing's decided yet. We're in a good position. Actually have a lot of universities courting us to try to join. So, we're not in a rush to do anything. We're going to evaluate options, but certainly open to that if there's a good fit. So hopefully bigger, hopefully doing many more projects than just 7. And, I hope to see that it's led to external projects, building relationships between faculty and government and industry that can submit proposals for funding from other sources, work on their own projects directly.
Well, thank you, David, so much for your time. We really appreciate you coming and telling us about the CQT, and we're excited to have you back in a few months, maybe about 5-6 months, so we can hear some of those exciting or interesting things that are coming out of the research projects. For those of you who are engaged with ATARC's Quantum Working Group, thank you. For those of you who are not, please reach out to ATARC. We'd love to continue to build the quantum ecosystem and make sure that we're able to have robust communications as well as interesting speakers like David.
Thank you very much, Allison.
Thank you, everybody. Have a great day.